Next topic is circular linked list. Circular linked list is exactly the same as the single linked list. Only difference is instead of having the null value here, I am having the memory address of the head node here. So a circle is created here, right? So instead of the null value in the last node, I am having the memory address of the first element. So this is known as circular linked list. So in the algorithm also only this new step has been added, that is only the new step has been added, that is n4 next, n4 का next is equal to n1 here. So that is the only difference. n1 n4 का next is equal to n4 here. So that is the only difference between circular linked list and the singly linked list. Again the first operation, that is insertion at the beginning. Insertion at the beginning is also the same. All of the steps will remain the same. Only the thing is a new node will be created here. All the steps are same. New node is there. Data part is assigned. After this data part, linking is there. So for linking, I have to basically and the next part of this new node should be having the address of the current head node, right? And the head should point here, and this should also have the address of this new node. So these three links have to be created. So for this link and this can be written by this statement, that is new node ka next is equal to head, new node ka next is equal to head. So that means 100 will be stored here, 100 value will be assigned here. So this step is done. Next step is head is equal to new node, new node instead of the value 100 here. Suppose the new node is stored at 1000 memory location. So instead of 1000 it will have 100, it will have 1000 here, right? So for now this third link has to be created. That means instead of 100 here, the value should have been 1000 here, right? So updating this value, I first need to traverse from the starting of the linked list to this element, right? So for traversing, again the steps will remain the same. I will take a temporary pointer variable here and initialize it to head, that is 100. Then I will go on traversing until the value becomes equal to this value becomes equal to head, until this current value is not equal to head. So once this becomes equal to head, so we will come out of the loop and this will be updated. So how will I update it? Current ka next. So current ka next. So current ka next is equal to new node here. New node address is 1000 here. So 1000 will be written here. This is also there in this case, right? So this is how a new node is created in the beginning. So next take me the case of insertion at the end. So insertion at the end is again the same as in the case of singly linked list. Let me delete these things. So yes, this is circular linked list. Now I have to insert a new element at the end. So for inserting the new element at the end, the steps are again the same. I will take a temporary pointer variable here. I will take a temporary pointer variable here, temp, and point it to head. That means it will have the memory address that is 100 here. So I will go on traversing until this position is achieved. That means first temp will point to here, then it will point to here, then it will point to here, then it will point to here. So now if it comes here temporary variable, then the temporary variable's pointer will be the last. Yes, it will have the temp ka next, temp ka temp का next is equal to temp का next is equal to head. So this is having 100 here, so it will go on traversing until the head comes here and the next part here. So after this we are out of the loop now. So now what I will do is create a new node here. A new node has been created, data part has been assigned to it. Then after assigning the data part, I have to basically insert this new node. So how will I insert? These pointers needs to be added now. New node ka next should have the address of the head here. New node ka next should have the address of the head here. So once this is done, this becomes equal to 100 now, right? So next step is temp ka next, present value of temp is 400, 400 ka next is 100 here. So instead of 100 here, it should have the memory address of the new node. So suppose the memory address of the new node is 1000 here. So instead of 100 here, it should have the value 1000 here. So temp ka next is equal to new node. So this way a new element is created at the end of the circular linked list. All the steps will remain the same, only this new step has to be added now, right? So next is insertion at the middle. Insertion at the middle is exactly the same as in the circular linked list. Not even a single statement will be changed. So next is deletion from the beginning. So now I want to delete from the beginning, right? So this is a circular linked list. Now I want to delete from the beginning. That means this element needs to be deleted now. This element needs to be deleted. So to delete this element, I just need to delete this pointer and instead have a new this new link has to be created, and this new link has to be created now. So only these two steps are there. So to implement these steps, first definitely I will have a new pointer variable here, and suppose I take it to be current here. It should have the memory address of head here. Head, that means 1000 here. Now both head and current are pointing to the first element. So I will write here is temp ka next, temp again the two see this link can be done easily. This link can be created easily with the help of this statement, head is equal to head ka next, right? So to change this particular pointer, I need to traverse from start till the end, right? So for traversing, I again require a temporary pointer variable here. It will also initialize to head, that is 100 here. Then I will go on traversing by writing temp is equal to temp ka next. So it will be traversed, it will be traversed, then it will be traversed, and at the last node this will be equal to head, that is the terminating condition is satisfied. Temp ka next is equal to head. So temp ka next is equal to 100 now. 100 is the head position here. So once this terminating condition is satisfied, we are out of the loop. Now I have to basically create this link, this. So that means I need to update the value of this 100 now. So to update the value of this 100, what I will write here? I will write here temp ka next is equal to head ka next. So head at present value of head is 100 here. So 100 ka next is 200. So 200 will be written here. Temp ka next is equal to head ka next. So after this I will free memory resource of this current. So this will be deleted with the help of this free operator. So that was all regarding the deletion from the beginning. Then next is deletion from the end. Again the steps will more or less remain the same here. Right? So yes, this is the circular linked list. So to delete the last element, so I have to basically delete this last element now. So now to delete this last element, I have to basically traverse starting from the previous starting from the initial, that is head, to this I have to traverse up till this, right? So I will write here, take a temporary variable here. I will take a temporary pointer variable here. It will point to the first element, that is head. Temp is equal to head. Then I will go on traversing further until temp ka next temp ka next is not equal to head. So that means I will traverse up till this temp ka next. So once this condition is satisfied, so I will be out of the loop. That means I have reached this node now. So I have to delete this node now, right? So how will I do it? I will take a current pointer variable here, and in this I will have the memory address. I will assign temp ka next. So this is my temp ka next is 400. So I will write here 400. That means this will point to this now, right? So once the current is pointing to this, next step is only one step, that is temp ka next. So temp ka next, this pointer needs to be updated now. If I want to delete this node, that means only this pointer needs to be updated. So instead of 400, it should have the memory address of this first element. So what I will write here is temp ka next is equal to the memory address of the head, that is head here. So this will be updated, and after this updation it will be 100 here. So that means this link will be created, and then I will resource, this memory resource will be freed with the help of free operator. So free current. So this will be deleted. So that was all regarding the deletion of a node from the end. Again, the next is deletion of a node from the middle. That is again exactly the same as in the circular linked list, right? So all the three topics are covered now. Okay.